When should analog signal filtering be used instead of digital filtering? In today's fast-paced world of technology, a pressing question arises for engineers and hobbyists alike. When should analog signal filtering be used instead of digital filtering? With the rapid advancements in electronic devices, understanding the best filtering methods is essential. Many are searching for clarity on this topic, especially as new applications emerge daily. Let's look at this question from an electrical engineering point of view. Both analog and digital filtering have their place, but there are clear situations where analog filtering is the better choice. Analog filters process signals directly in their original, continuous form. They are built with resistors, capacitors, inductors, and sometimes operational amplifiers. Digital filters, on the other hand, requiring the signal to be converted to digital from using an analog to digital converter, processed by a digital signal processor or microcontroller, and then converted back to analog if needed. One significant reason to choose analog filtering is speed and real-time response. Analog filters work instantly, with no delay from sampling or computation. This makes them ideal for applications where the signal must be filtered in real time, such as in radio frequency circuits or when protecting sensitive equipment from fast transients. Another factor is simplicity and cost. For basic filtering tasks, like removing high-frequency noise from a sensor signal, a simple resistor capacitor or inductor capacitor filter is often cheaper and easier to implement than a digital solution. No analog to digital converter, digital to analog converter, or programming is needed. Power consumption is also a consideration. Analog filters can be very power efficient, especially passive ones. Digital filters requiring active components and processors that consume more power, which matters in battery-operated devices. Handling high-frequency signals is another area where analog filters excel. They can process signals at very high frequencies, limited only by the components used. Digital filters are limited by the Nyquist rate, meaning the signal must be sampled at least twice as fast as its highest frequency component. For signals in the megahertz or gigahertz range, analog filtering is often the only practical option. Additionally, analog filters do not introduce quantization noise, which is a byproduct of the analog to digital conversion process in digital systems. This can be important in high-precision applications. However, digital filtering has its strengths. Digital filters excel when flexibility, precision, and programmability are needed. They can implement complex filter shapes, adapt to changing conditions, and are easy to modify in software. They are also better at handling very low frequencies, where analog components would be impractically large. In summary, use analog filtering when you need fast, simple, low power, or high-frequency signal processing. Use digital filtering when you need advanced, adjustable, or software-based filtering capabilities. The choice depends on the specific requirements of your application.